Okay, so let's start new topic, a random sequence synchronous counter using D flip-flop. Random sequence counter means which can count a random numbers, and synchronous circuit means which uses the same clock pulse to all the flip-flop. And to design the random sequence, we will use D flip-flop. So next, we will take one example. For example, we will design a circuit which will count like 5, then 2, then 1, then 7, then 3, then for example 5 and so on. What does it mean? The first number is counting as 5, the next number will be 2, next number as 1, then 7, then 3, and again 5. And after 5 again 2 and so on. After 2, 1, 7, 3, then 5, 2, 1, 7, 3, 5, 2, 1, 7, 3. Understand? So we will design a circuit which can count like this. So what are the steps we need to follow to design a random sequence counter? Here we will draw a state diagram first. So first step will be the state diagram. Then we will draw the state table. Along with that, we require the excitation table of that particular flip-flop for which by which we will design the circuit. As we are using D flip-flop here, we require the D flip-flop excitation table. After that, we will use the K map to find out the expressions for the D flip-flop inputs. And later we will draw the circuit diagram. These are the 4 steps by which we can design the circuit. Let's see what first step, that is the state diagram. Here I'm writing the question. We will design a circuit like 5 which can count like this: 5, 2, 1, 7, 3, and then 5 again, 2, 1, 7, 3, 5, like that. So what is the meaning of state diagram? We will write down 5 first. So in the binary form you have to represent 5. In the binary will be represented as 1, 0, 1. Then 2 will be represented as 0, 1, 0. Then it is represented, 1 is represented as 0, 0, 1. Next is 1, 1, 1 because 7 is represented as 1, 1, 1. Next number is 3, that is represented as 0, 1, 1, and then 5. So it's complete circle and it's called as the state diagram. Now, by using this state diagram, we have to draw the state table. In the state table, what are the parameters? In the state table, we have basically 3 parameters. One is present state. Next is next state. So first we will draw the present and next state, and then we will think about the flip-flop inputs. So here, as we are taking 3 bits for the representation. Why we have taken the 3 bits? Because the largest number here is 7, and to encode 7 we require minimum 3 bit, that is 111, right? So here we are using the 3 bits. So here in the present input we will have QC, QV, and QA because we are using 3 bits. And because by using the 3-bit, total possible combinations will be 8. I'm writing all the 8 possible combination here: 0, 0, 0, 1, 1, 1, 1. Right now it's 0, 0, 1, 1. That means by using the 3 bits, total 8 possible combinations are there. I'm writing all the 8 possible combinations like this. Now it is called as the present state. For example, you are in the state 0, 0, 0. What will be the next state? Now, if you see the state diagram, here we don't have 0, 0, 0. If that particular state is not there in the state diagram, that means it's a don't care because we cannot tell the exact value here, right? So here it is QC plus 1, QB plus 1, and QA plus 1, which indicates this is the next state. Okay. If you are in the state 0, 0, 1, what will be the next state? 0, 0, 0, 1. So if you are in 0, 0, 1, next state will be 1, 1, 1. Correct? So here you write down 1, 1, 1. Now if you are in state 0, 1, 0, 0, 1, 0, then the next state, if you are in 0, 1, 0, then next state will be 0, 0, 1. You write down 0, 0, 1 here. 0, 0, 1. Clear? Now, if you are in state 0, 0, 1, 1, so you see 0, 1, 1, 0, 1, 1, then next state will be 1, 0, 1. 1, 0, 1. Now, if you're in state 4, what will be the next state? But if you see in the state diagram, there is no state which have 1, 0, 0 value. That means it's a don't care because we cannot tell the next state after that, right? So it's a don't care condition. If you are in state 5, what will be the next state? If you are in state 5, the next state, if you are in state 5, the next state will be 0, 1, 0. 5 to 2. So 0, 1, 0. If you're in state 6, 1, 0, 0, 1, 1, 0, then what will be the next state? As you can see, there is no such states which value is 1, 1, 0. That means we cannot tell the next state. In that case, you assume as a don't care conditions. Now, if you're in state 1, 1, 1, what will be the next state? From 1, 1, 1, next state is 0, 0, 0, 1, 1. 0, 1, 1. Clear? So now this is the present and next state. Now here we have to find out the value of DC, DB, and DA because we will use D flip-flop for designing the circuit. Clear? So now here we will see excitation table because as we are designing by using the D flip-flop, we should know the excitation table of D flip-flop. Excitation table of D flip-flop. It is given as Qn plus 1, and this is the D 0, 0, 1, 1, 0, 1, 0, 1. This is 0, 1, 0, 1. So the important point here is what? Whatever will be the next state value, it will be similar to that of D. That means what? If you want to find out the value of DC here, it is similar to that of QC plus 1. So directly I can write down the value here. It is what? Don't care 1, 0, 1, don't care 0, don't care 0. That's it. Understand? Similarly, what will be the value of dB? dB will be equals to that of QB plus 1. So don't care 1, 0, 0, don't care 1, don't care 1. Similarly, what will be the value of QA plus? So this DA will be equals to QA plus 1, and it will be represented as don't care 1, 1, 1, don't care 0, don't care 1. Now we have all the values and this state table is completed. Now we will go for the K map for finding the value of DC, DB, and DA. So now here we will draw the K map for finding the expression for DC and how many input variables are there. We will have 3 input variable because present state will be the input variable QC, QB, and QA. So here we will draw the 3 variable K map like this, where we will take QC this side and QB, QA this side. This is 0, this is 1, 0, 0, 0, 1, 1, 1, 1, 0. Because here we will use the gray code for the K map, right? So here, if you see, wherever your function values either don't care or 1, you fill the value here. So don't care 1, 0, 1, right? So don't care 1, don't care 1, 0, 1, right? Next one is don't care 0, don't care 0. So don't care 0, don't care 0. Just 0 only, no need of writing here. Now you see which type of group is possible here. Quad is not possible. You can make only the pair here. So the expression for DC will be given as QC bar QA. Now we will see how to draw the K map for DB. So in case of DB, again, we have to draw the 3 variable K map like this. This side you take 0, 1, this side is 0, 0, 0, 1, 1, 1, 1, 0. This side you take QC, this side QB, QA. Now, wherever your function DB is 1 or don't care, you fill the value here. Just don't care 1, 0, 0. So don't care 1, then 0, 0. Then don't care 1, don't care 1. Just don't care 1, don't care 1. right? So here, if you see, we can make two quads. One quad like this, another quad like this, right? So now here, what will be the expression? DC will be given as QB bar, another one will be QC, right? Similarly, the expression for DA will be calculated by using the three variable K map like this, and which will be given and drawing like this. This is 0, this is 1, 0, 0, 0, 1, 1, 1, 1, 0. And if you see the table here, and it's what from DA, so don't care 1, 1, 1. So here you draw, don't care 1, 1, 1. Then it's don't care 0, don't care 1. Don't care 0. So it's don't care 0, don't care 1. So now this is the table. So I can make one group like this, and I can make one group like this. So the expression of DA will be given as QC bar plus QB. Now we already calculated the expressions. I'm writing it here again. So DA, DB, this was DB. So DB will be given as QB bar plus QC. Similarly, we have seen the DC expression, that is QC bar QA. Now we have all the expression to draw the circuit diagram. Here I am drawing it. So as you can see, we require three D flip-flop. So here you can draw it like this. This is first D flip-flop, second D flip-flop, and third D flip-flop. Which will be A and which will be C? So always remember the most significant bit will be the last one. Okay, so this is the C. This is D flip-flop and I am representing C here. This is D flip-flop, I am representing by B here. This is D flip-flop, I am representing by A here. Now we have all the expressions. So here you see for DA, it's QC bar QB. So I am drawing it like this, one OR gate. And here I will provide QC bar. This here I am providing QB. Similarly, here it's DB and DB will be calculated by using the OR gate. And this is QB bar QC. Similarly, I will use one AND gate here, and here I will provide QC bar, and this is QA. The input will be given as the DC. So now this is DB, this is DA. We already have made the connections, but the important point is what? As this is the synchronous circuit, we have to provide the same clock to all the flip-flops like this. And here you will get QA, from here you will get QB, from here you will get QC. You can also draw the inverted outputs like QA bar, this is QB bar, and this is QC bar. That's all for this lecture. Thank you everyone for watching.